Picture this. It's June 30th, 1908. The sun is rising over the remote forests of Siberia when suddenly the world changes forever. A fireball blazes across the sky, 40 times brighter than the midday sun, streaking through the atmosphere at an unimaginable speed. Then, in an instant that would puzzle scientists for over a century, something explodes with the force of 1,000 atomic bombs. Welcome to the story of the Tunguska Event, the most mysterious and devastating explosion in recorded human history. I'm your host, Ryan Martin, and today with The Conspiracy Tapes, we're diving deep into one of science's greatest unsolved puzzles. What you're about to hear will challenge everything you think you know about objects from space, natural disasters, and perhaps even our place in the universe. The explosion that morning in 1908 was so powerful it could have obliterated London or Tokyo. Trees were flattened in a perfect radial pattern, extending at least 15 kilometers from the blast center. The shock wave was felt thousands of miles away. Bright nights illuminated the skies across Europe and Asia for days afterward. Yet, here's the truly baffling part. No impact crater was ever found. If unraveling history's greatest mysteries excites you, make sure to like, subscribe, and follow this podcast on Apple Podcasts, Spotify, YouTube, or wherever you listen. And for even more mind-bending stories, check out Scoob, the AI-powered podcast studio app that curates the world's most fascinating shows just for you. Download Scoob from the App Store or Play Store and keep your curiosity burning bright. Now, let's journey back to the heart of Siberia and uncover the true story behind the Tunguska Event. For years after the explosion, the Tunguska site remained virtually untouched. Russia was in political turmoil, and the remote location made investigation nearly impossible. It wasn't until 1910 that the first expedition reached the area, led by a Russian merchant named Zdenek. Mysteriously, upon his return, he advised locals to keep his findings confidential. What did he discover out there? We may never know. But the real scientific investigation began much later. When researchers finally reached the blast site, what they found defied all conventional explanation. The forest devastation showed an almost perfect radial symmetry. Trees blown down like matchsticks, all pointing away from a central location. Yet, at the very center of this devastation stood something extraordinary. Stripped tree trunks, standing like bare telephone poles. Scientists would later call these Kulik's telegraph poles, after one of the early researchers. The absence of an impact crater became the defining mystery. If a massive object from space had struck Earth with enough force to cause such devastation, where was the crater? Where were the fragments? The more scientists studied the site, the more questions arose. In the late 1950s, researchers subjected soil samples to intense laboratory testing under powerful magnification. What they discovered would fuel decades of speculation. The soil contained an abundance of tiny spherical globules, each just a few millimeters or less in diameter. These mysterious particles were primarily composed of silicate and magnetite, a magnetized iron oxide shaped like droplets or bulbs. Here's where it gets really interesting. These particles appeared to have coalesced under intense heat conditions, similar to trinitite, the glass-like substance produced at nuclear test sites. Were these simply cosmic dust that constantly falls to Earth, or were they fragments of whatever caused the Tunguska explosion? For decades, the leading scientific explanation pointed to the cosmos, specifically to a fragment of a comet. This theory emerged as the most plausible explanation consistent with the observed facts, and here's why it made sense. Space between planets hosts countless objects of varying composition: rocky, metallic, icy, and organic molecular structures. These range in size from dust particles to massive, irregularly shaped blocks comparable to smaller countries like Nicaragua or Bhutan. Occasionally, Earth finds itself in the path of one of these wandering objects. The Tunguska object, according to comet theorists, was likely about 100 meters in diameter, roughly the size of a football field, weighing around 1 million tons and traveling at approximately 30 kilometers per second, or about 70,000 miles per hour. Now, here's the crucial part. Comets are essentially cosmic snowballs, consisting primarily of ice, water, methane, and ammonia. When a comet strikes Earth's atmosphere, it creates a brilliant fireball and powerful blast wave. The intense heat can incinerate forests and create sounds audible across continents. But here's the key to solving the crater mystery. The ices would melt and vaporize during atmospheric entry, leaving minimal recognizable debris on the ground, perhaps just small grains from the comet's non-icy components. This explanation gained significant support when Soviet researcher E. Sobotovich discovered numerous tiny diamonds scattered across the Tunguska region. Similar diamonds are known to exist in meteorites and may originate from comets, providing tantalizing evidence for the cometary theory. But the comet explanation also carried alarming implications for our modern world. If a similar impact occurred today, the immediate reaction might be to mistake it for a nuclear explosion, complete with mushroom cloud. Unlike a nuclear blast, however, it wouldn't produce gamma radiation or radioactive fallout. In our current geopolitical climate, such a misidentification could potentially trigger a nuclear conflict. This concern isn't purely theoretical. On September 22, 1979, an American Vela satellite detected an intense double flash over the South Atlantic and Western Indian Ocean. Initial speculation suggested a clandestine nuclear weapon test by countries like South Africa or Israel. However, investigations revealed no unusual radioactivity, suggesting the possibility of an asteroid or comet fragment causing the flashes. This incident highlighted the urgent need for better space impact monitoring to prevent catastrophic misinterpretations. But wait, not everyone was convinced by the comet theory. In 1983, astronomer Zdenek Sekanina published groundbreaking research that would fundamentally challenge the comet hypothesis. After carefully examining half a century's worth of Tunguska research, Sekanina proposed a completely different explanation. The culprit was an asteroid, not a comet. Sekanina's analysis was methodical and devastating to the comet theory. He estimated the object's size between 90 and 190 meters and determined its trajectory to be approximately 110 degrees east of north at a shallow angle of about 5 degrees above the horizon. The asteroid exploded roughly 8 kilometers above the ground at the staggering entry speed of about 108,000 kilometers per hour. What made Sekanina's work so compelling was how it explained the physical evidence at the site. The lack of impact craters or significant fragments suggested the object disintegrated entirely in the atmosphere, something more consistent with an asteroid than a comet. The forest devastation's almost perfect radial symmetry, with flattened trees extending at least 15 kilometers from the explosion center, pointed to a single, massive detonation, rather than the multiple fragmentation events you might expect from a friable comet. Sekanina's analysis revealed there was just one enormous explosion, effectively ruling out the possibility that the object had fragmented during its atmospheric entry. If fragmentation had occurred, it would have created a series of smaller detonations rather than the singular massive explosion that released over 12 megatons of energy. The fireball from this explosion dissipated an immense volume, 1 million tons of small particles, in a fraction of a second. These particles were swiftly scattered into the atmosphere by the explosion's shock front, contributing to the unusual bright skies reported across Europe and Asia in the days following the event. Perhaps most importantly, Sekanina addressed the pressure dynamics involved. He argued that comets, with their friable compositions, simply couldn't have survived the high pressure the Tunguska object withstood before detonating. This observation alone seemed to eliminate the comet hypothesis and strongly support the asteroid theory. Sekanina's work significantly reinforced the notion within the scientific community that Tunguska was indeed a major impact event, reviving interest in detecting and understanding near-Earth objects and catalyzing efforts to monitor potentially threatening asteroids and comets. Just when you thought the mystery couldn't get any stranger, along comes Wolfgang Kundt, a renowned professor of astrophysics at the University of Bonn, with a theory so radical it turns everything we think we know about Tunguska on its head. Kundt dismisses both the comet and asteroid theories as pseudoscience and proposes something completely different: a massive volcanic blowout involving natural gas. According to Kundt's theory, the Tunguska event wasn't caused by anything from space at all. Instead, natural gas, primarily methane, escaped from underground volcanic vents through narrow openings deep in the Earth. As this gas shot upward at high velocity, it mixed with air and became electrically charged, creating a volatile mixture that, after a few hours, was ignited by a lightning strike. The resulting fireball, Kundt suggests, comprised approximately 10 million tons of natural gas, enough to cause the catastrophic damage observed at Tunguska. This theory gains credibility when you consider that Tunguska sits within the Kulik volcanic crater, dating back about 250 million years. The region is riddled with faults and fractures running through rock layers. Kundt proposes that the gas escaped through a kimberlite, a unique volcanic pipe shaped like a carrot that forms when magma from Earth's mantle pushes upward. These formations, called diatremes, are where diamonds form deep beneath the Earth, approximately 150 kilometers down, and are brought to the surface by volcanic activity. Named after the diamond-rich Kimberley area in South Africa, kimberlites have since been discovered globally. This connection to diamond formation is particularly intriguing given the discovery of tiny diamonds in the Tunguska region. Rather than evidence of a cosmic impact, Kundt suggests these diamonds formed during the natural gas eruption that created the kimberlite pipes. Kundt's theory also addresses several puzzling aspects that other theories struggle to explain. The vast number of severed tree stumps scattered around the area, and the peculiar treefall patterns don't match what you'd expect from a single large explosion. Instead, they suggest multiple, sequential explosions occurring at different locations. A 1991 Italian expedition's detailed analysis of the treefall pattern supports this notion of multiple explosion centers. The radial pattern of fallen trees doesn't follow straight lines. It wiggles and follows natural contours like valleys and hills, contradicting impact models that predict parallel treefall patterns. The explosion also created numerous funnel-shaped holes, including the well-known Suslov crater. Evenki witnesses reported that these craters formed when material was blown from beneath on the day of the explosion. Kundt theorizes that water infiltrated these crater cavities upon their formation, rather than the ice crystals being evidence of permafrost as Russian scientists suggested. Even the famous bright nights across Europe and Asia following the explosion find explanation in Kundt's theory. He believes methane gas rose to an altitude of 200 kilometers and underwent reheating by solar radiation. The slow combustion with atomic oxygen allowed the gas to rise further, reaching approximately 600 kilometers in altitude. This process created water vapor that crystallized into snowflakes, scattering sunlight and causing the intensely bright nights. similar to those observed after the 1883 Krakatoa volcanic eruption. Now we enter perhaps the most controversial territory in the Tunguska mystery. What if the explosion wasn't caused by a natural phenomenon at all? What if it was evidence of our first contact with extraterrestrial intelligence? This extraordinary theory began with Alexander Kazantsov, an eminent writer and former engineer who graduated from Siberia's Technical Institute in 1930. In 1946, Kazantsov published a seminal short story titled The Blast in one of the Soviet Union's most popular science and adventure magazines. His narrative proposed that the Tunguska explosion was caused by an interstellar cosmic visitor, essentially a UFO. Kazantsov envisioned a cylindrical craft powered by nuclear fuel. According to his theory, a malfunction caused this alien vessel to spiral uncontrollably toward Earth, culminating in a catastrophic crash that vaporized both the ship and its occupants. The visitors, he suggested, were en route to Lake Baikal, located roughly 800 kilometers from the impact site, and renowned as the world's deepest freshwater body. What started as science fiction quickly gained serious scientific attention. Kazantsov's hypothesis found an unexpected supporter in Eyewitness, an esteemed aircraft designer who endorsed the extraterrestrial theory, arguing that the Tunguska object showed signs of intelligent control. Monotkov's analysis focused on the object's unusual flight characteristics. While standard meteoric and cometary entries into Earth's atmosphere typically occur at velocities between 36,000 and 216,000 kilometers per hour, the Tunguska object reportedly decelerated to approximately 2,400 kilometers per hour, comparable to a modern fighter jet. This dramatic deceleration suggested the possibility of controlled flight rather than a simple ballistic trajectory. Moreover, Monotskov calculated that if the object had been a conventional meteorite, it would have needed a mass of at least 1 billion tons and a diameter exceeding a kilometer to cause such devastation. Yet no residual fragments or distinct impact crater were ever found, an absence that seemed impossible for such a massive conventional impact. The UFO theory gained additional credibility as scientists analyzed the mysterious particles found throughout the blast area. Chemical analysis revealed small quantities of cobalt and nickel, alongside traces of copper and germanium. Kazantsov argued these elements supported his spacecraft theory. A technological craft would naturally contain electrical and technical instruments, including copper wires and communication devices that might employ germanium-containing semiconductors. Even prominent figures in Soviet space science seemed intrigued by these possibilities. Boris Laipunov, a leading expert in Soviet space and rocket technology, appeared to share views similar to Kazantsov and Monotskov, further legitimizing the discourse surrounding the event's extraterrestrial origins. Kazantsov continually revised his story to incorporate new scientific findings. When the 1958 expedition revealed metals like cobalt, copper, and nickel at the site, he modified his narrative to suggest these were remnants of the spacecraft's hull and internal components, vaporized during the explosion and scattered across the blast area. But some theorists took the extraterrestrial hypothesis even further. Enter Felix Zolotov, a Soviet researcher who developed what he called an atomic hypothesis about the Tunguska event. Drawing inspiration from Kazantsev's ideas, Zolotov added a revolutionary twist. The explosion wasn't accidental, it was intentional. Zolotov proposed that an extraterrestrial spacecraft deliberately detonated as a means of making contact or signaling to humanity. This idea suggested an element of precision and intent in the devastation that had never been considered before. American writer T.R. Lemaire expanded on this theory in 1980, highlighting the explosion's timing as too coincidental to be accidental. Lemaire pointed out that if the event had occurred just 4 hours and 47 minutes later, it might have struck the heart of Tsarist Russia, or could have devastated heavily populated areas of China or India instead of the remote Siberian forest. According to Lemaire, the extraterrestrial vehicle may have been under intelligent guidance, using geographic landmarks like Lake Baikal for navigation. The object's path allegedly included sharp turns before ultimately exploding over an uninhabited forest, deliberately minimizing human casualties while still delivering an unmistakable message to Earth's inhabitants. However, this theory faced scrutiny when comprehensive scientific analysis of eyewitness testimonies revealed that, contrary to claims of abrupt directional changes, the object actually moved steadily from south-southeast to north-northwest without deviation. Zolotov's contribution extended beyond speculation about alien intentions. He introduced the crucial question of radioactivity at the site. He suggested that survivors of the explosion were exposed to radiation levels similar to those observed in Hiroshima after the atomic bombing, adding a layer of scientific inquiry to what had been primarily speculative fiction. Soviet scientist Felix Zigel supported these investigations, reporting that Zolotov's expedition studied ballistic and blast wave effects on trees within the affected area. Their findings were intriguing. Ballistic waves from the west only damaged smaller branches, while the blast from the north caused significant disruption. Based on these observations, Zigel recalculated the object's velocity at a relatively modest 4,300 kilometers per hour, suggesting that the explosion's devastating force derived not from kinetic energy, but from the object's internal energies. But was there actual evidence of nuclear activity at Tunguska? The answer became increasingly compelling as researchers dug deeper, literally. Investigators discovered peculiar scabs on the skin of reindeer that survived in the vicinity of the explosion. Trees surrounding the blast site revealed another startling detail. When cut down, their growth rings showed a significant increase in growth rate following 1908, suggesting unusual environmental changes. Most significantly, the investigative team discovered remarkably high levels of carbon-14, a radioactive isotope, in both the peat and soil they collected from the blast area. This array of unusual findings strongly suggested substantial radioactivity had been present at the site. These discoveries led to the establishment of the interdisciplinary independent Tunguska Expedition, KSE, in the 1950s and 1960s. Based in Tomsk, Siberia, these scientists were often jokingly said to have a primary mission of debunking the prevalent alien spaceship theories that had captured Russian imaginations. The KSE team explored potential radiation-related health issues among the Evenki people who lived near the Tunguska Event Zone. Medical students compiled data from local populations but struggled to find clear signs of radiation-related illnesses. They even attempted to analyze remains of individuals who had died since the explosion, though this proved challenging due to the Evenki community's reluctance to disclose burial sites. Despite these obstacles, researchers managed to examine some remains, particularly of individuals who had died in a 1915 smallpox epidemic. Analysis showed no trace of illnesses attributable to significant radiation exposure. From the blast site, scientists collected approximately 100 plant samples and 300 soil samples, all analyzed in Tomsk's KSE laboratories. The results were telling. Radiation levels at the blast's epicenter were between 1.5 to 2 times higher than those found in soil samples taken 40 kilometers away. However, the researchers refrained from speculating about the possible causes behind these elevated radiation levels. So here we stand, more than a century after that fateful morning in 1908, with multiple compelling theories but no definitive answer. Each explanation, whether cosmic, terrestrial, or extraterrestrial, addresses certain aspects of the evidence while leaving others unexplained. The comet theory elegantly explains the lack of crater and significant debris, supported by the discovery of tiny diamonds throughout the region. The asteroid hypothesis, backed by Sekanina's rigorous analysis, better accounts for the explosion's characteristics and the object's ability to survive atmospheric pressure until detonation. Kuntz's volcanic gas theory offers explanations for the multiple explosion centers and unusual treefall patterns that single-impact theories struggle to address. Meanwhile, the UFO theories, however speculative, attempt to account for the object's unusual flight characteristics and the presence of elements like copper and germanium in the blast debris. The nuclear evidence, elevated radiation levels, affected wildlife, and enhanced tree growth, adds another layer of complexity that no theory fully explains. Perhaps the most sobering aspect of the Tunguska mystery isn't what happened in 1908, but what it means for our future. In our current world of nuclear weapons and hair-trigger international tensions, a similar event could easily be misinterpreted as an attack, potentially triggering catastrophic retaliation. The 1979 Vela satellite incident serves as a stark reminder of how cosmic events can be mistaken for hostile actions. Whether Tunguska was caused by a comet, asteroid, volcanic eruption, or something more exotic, it represents a type of natural phenomenon we still don't fully understand. In an age where we monitor space for potentially hazardous objects and maintain global nuclear arsenals, understanding events like Tunguska isn't just an academic exercise, it's a matter of planetary survival. The brilliant spheres of fused material scattered across the blast site, the patterns of destruction that defy simple explanation, the radioactivity that lingers more than a century later, all of these elements continue to puzzle scientists and fuel new theories. What we do know is this. On June 30th, 1908, something extraordinary happened in the skies above Siberia. An object, natural or otherwise, released energy equivalent to hundreds of Hiroshima bombs, flattened 2,000 square kilometers of forest, and left behind evidence that still challenges our understanding of physics, astronomy, and perhaps even our place in the universe. The Tunguska Event remains one of science's greatest unsolved mysteries, a reminder that our planet exists in a cosmic shooting gallery we're only beginning to understand. Whether the next such event comes from a comet, asteroid, volcanic eruption, or something we haven't yet imagined, the lesson of Tunguska is clear. We ignore the skies above us at our peril. Until we solve this century-old puzzle, the forests of Siberia will continue to hold their secrets, and the mystery of that blazing fireball will continue to challenge our understanding of the cosmos and our fragile place within it. Thank you for joining me on this journey into one of history's greatest mysteries with yours truly, Beatrice Goodwin, and this has been The Conspiracy Tapes. The truth about Tunguska may still be out there, waiting to be discovered. Until then, we can only look up at the sky and wonder what might be coming our way. If you enjoyed this episode, don't forget to like, subscribe, and follow us on Apple Podcasts, Spotify, YouTube, or wherever you listen. Your support helps us bring you more incredible stories from the edge of science and history. And if you're hungry for more mysteries and mind-expanding content, check out Scoob, the AI-powered podcast studio that curates the world's most fascinating shows just for you. Download Scoob from the App Store or Play Store and keep your curiosity alive wherever you are. Until next time, keep exploring and keep questioning the realities around us.